So, finishing up, we have a lot of sections, but they're all very closely related. In 12.1, we're going to talk about solving systems of equations by the graphing method, which actually turns out to be a terrible method, so we're not going to spend a lot of time on it. But it's a good introduction to the concept of what is going on. So first up, let's define what it means to be a system of linear equations. So we have a couple of examples here, and often you'll see systems presented with a curly bracket on the left, right, those braces on the left. X minus 3y equals negative 5, 2x plus 4y equals 10. This is a system of equations. Y equals 1/4 x minus 3/4, negative 2x plus 8y equals negative 6. That is a system of linear equations. 5a plus b equals 4, negative 10a minus 2b equals 8. That is a system of linear equations. So we've seen linear equations before. That's not new. So what do you think a system means? We just have more than one. They are related. So a system of equations just means you have more than one. Now, does that mean you can only have two? No, we can have more than that. We'll see something like that pop up. But for a 2x2 system, two equations are all we need. All right? So what does a solution look like? So let's say I give you x minus y equals 2, x plus 3y equals 6. And I tell you the answer. That's the only time this is going to happen. The solution is the ordered pair 3, 1. So I have my solution set, those braces, right? And then I have in there that ordered pair 3, 1. How many solutions is this? Very good. There is one solution. It consists of an ordered pair. So 3, 1 is a single solution. By convention, we list the x and the y in that order. X first, y second. All right. Is that okay? So what does it mean to be a solution?
Get a true statement. Plug it in.
Yeah, if I plug it in, I get a true statement. Only this time it has to be true for both of them. So if I plug in 3 minus 1, is that 2?
Yes.
Okay, a little delay there gave me a heart palpitation. 3 plus 3 times 1, is it 6?
Yes.
Then this is my solution. Is that okay? Now, we know that individually, each of those equations are lines, right? So couldn't I just graph them? I mean, I'm going to try. Let's see what kind of damage we do.
Oh, wow.
Oh, is that the first time I busted that out on you guys?
Yeah.
Ah, there you go. I got fancy tools.
Whoa.
All right. So what do we need to graph a line? How many points?
At least two.
2 points, right? 2 points, and you can nail down a line, right?
Yeah.
Easiest 2 points usually to get involve the intercepts, right? So we remember, if I look at this first equation, x minus y equals 2, set y equal to 0, and what do I get? X equals 2. So there's that x-intercept of 2. If I set x equal to 0, I get, and that means y equals negative 2. So y equals negative 2 is the y-intercept.
Pen keeps falling.
I know. So here is the line that represents all the points that make x minus y equals 2 true. All right, what about the second equation, x plus 3y equals 6? If I set y equal to 0, I get x equals 6 for the intercept. If I set x equal to 0, I get y equals 2. Y equals 2 as my intercept. So that line represents all the points that make x plus 3y equals 6. All right? So what would the solution to the system do? You guys said it had to make both of them true, right? So where do I find a point that makes both of them true? Where they cross? And where do they cross? There it is. All right? So intuitively, this is a great way to digest what we're talking about when we talk about a system and a solution to the system. So the point that makes both of them true would be a point that both lines pass through, which is their intersection. All right? And that's great. We can talk about some geometry. All right? How can two lines cross? Well, they could just cross at a single point, in which case we have one solution, that coordinate pair. All right? Now, whether you put those braces on or not, I don't care. But the parentheses for the coordinate pair are non-negotiable. If you tell me the answer is just 3, 1, that's not the same thing as the coordinate point 3, 1. And there is a difference, and I will persnick, so get it right. Okay. However, if two lines are parallel, where do they cross? They're never going to cross, no matter how far out you go. So what would the solution be to that system? There wouldn't be one, right? No solution. We may have the second line lie atop the first line, touching it infinitely many ways. Right? So what do we have there besides a lawsuit? Well, there are infinitely many solutions, but that doesn't tell me what the solutions are. For example, would this point down here be a solution? No. Would this point up here be a solution? No. So, although there are infinitely many solutions, what are the solutions? All points on the line. Right? There are infinitely many, but that doesn't mean just any old point is a solution. It's specifically all the points along the line. Is that okay? All right? So, when I ask you for the solution, you do not tell me infinitely many, because that didn't even answer the question. All right? Worse, do not tell me all real numbers. We're not on a number line. Where are we? We're in the plane. So you have coordinate pairs. So that even means you don't even know where you are. Right? That will make me a cranky grader very fast. All right, so just to kind of summarize that. When we talk about these three cases, we either have one unique solution, no solution, or infinitely many. And we would say, if we have a solution, the system is consistent. So notice that the first and third cases, the system is consistent. So what does it mean? It means there's at least one solution. If you have solutions, it's consistent. What if you don't? Inconsistent. We have these cute little definitions in math. It's inconsistent if it's not consistent. The first and second cases, we say that the lines are independent, meaning that they are separate lines. Each is its own line. Therefore, they are independent. Whereas in the third case, we say they are dependent. If they're not independent, then they are dependent. Another one of those cute definitions. So we usually just cut this down because there's 6 things here. We usually just cut it down to the part that makes it stand out. The middle one is inconsistent. That's what makes it stand out. And the third one is dependent because they're not separate lines. And that's what makes that one stand out. All right? Some terminology, not tragically important, but it's there. All right. So here's the thing. It was great that my solution here wound up being 3-1. But what if the solution had been 6/5 negative 5/3? Anybody gonna eyeball that one? Not me, and it's not just because I'm blind. All right. Graphing method is not a great method for actually solving. It's great for the theory of what's going on and getting an understanding of what we're doing, but it's a terrible method. So we're just going to move on. In 12.2, we're going to talk about solving a system by substitution method. Now this is going to be a good algebraic method, so we're going to be able to use this to solve a system even if the answer is gross. So solving a system of equations by substitution. You pick one of the variables from one of the equations and you solve for it. So that means you either pick x in the first equation, y in the second equation, whichever one floats your boat, and you solve for it. Then you substitute, hence the name of the method, in the other equation. All right? Solve the resulting equation, which should just have one variable, and then you've got a piece of the puzzle. But your solutions are coordinate pairs, which means you need both an x and a y. So whichever one you solve in step 3, you have to back substitute to find the other component. And then it's always good to check, although as long as you do legal maneuvers, your solution should be good. Right? It's not like one of those cases with the radical equations where you can actually pick up extraneous solutions. So let's see how this works. Let's see how substitution works. Let's say that I give you 3x minus 2y set equal to 5, and I give you 3x minus y set equal to 3. So here's the system. So pick one of the variables in one of the equations. So let's say that I call them 1 and 2. I know I'm being super creative here, but whatever. Which one do you pick?
2.
And if we pick equation 2, which variable do you want to solve for? Okay, so normally you guys are pretty good at picking out the limping zebra on the savannah. Right? In theory, any of the 4 choices is fine. In practice, some choices are better than others. If I solve the second equation for y, that's a good choice because I'm not going to divide and make fractions. You guys are allergic. Right? So that's the limping zebra. That's the one we take down for dinner. Right? So we'll take the second one. 3x minus y equals 3. And I can solve it for y by... Okay. If I subtract the 3 to the left and add the y to the right, that's the most direct way to do it. You guys all on board with that? So 3x minus 3 equals positive y. Is that okay? So that was step 1, right? We picked one of the variables in one of the equations and we solve for it. Then we substitute that into the other equation. So this means I go over to 3x minus 2y equals 5, but I don't want just any y. I specifically want y to be 3x minus 3. So that means I have 3x minus 2 times 3x minus 3 set equal to 5. Do you guys see how I substituted in? Right? Wink, wink, nudge, nudge, the name. Well, we can solve this equation. 3x minus 6x plus 6 set equal to 5. You guys agree? Combine like terms, that means negative 3x plus 6 equals 5. Then what? If I subtract 6, then negative 3x equals Negative 1. And finally, divide both sides by negative 3, and x equals 1/3. You guys see how I did that?
Yes.
But that's only part of the story. So what do we have to do? Back substitute for y, which we conveniently have an equation for. So I have 3 times 1/3 minus 3 equals y. You guys agree? What's 3 times 1/3? 1 minus 3 equals y, so y is negative 2. You guys agree? So what's my solution? Yep. How many solutions do I have? One solution. The coordinate pair, 1/3, negative 2. The parentheses are non-negotiable. So this was consistent or inconsistent? Consistent. We had a solution, right? This was independent or dependent? Independent, right? Really, it was just the special cases. The no solution is inconsistent, and the infinitely many is dependent. Right? Those were the kind of special cases. How do you guys feel about that one? Pretty easy, right? What if I give you x over 3 plus 2y equals negative 1, x plus 6y equals 2. Another system, let's solve it by substitution. Who's the limping zebra? X in the second one? We can do that. So we'll pick the second one. X plus 6y equals 2. And I can solve it for x by...
moving the 6.
Yeah. Subtract 6y over. So x equals 2 minus 6y. You guys agree? All right, then what do? We substitute that into the other equation. So we wind up with, instead of x over 3, 2 minus 6y over 3 plus 2y equals negative 1. How do we solve this equation? By multiply everything by 3. So 2 minus 6y plus 6y equals negative 3. Do you guys agree? If I combine like terms, I wind up getting negative 6y plus 6y to cancel out. And I wind up with 2 equals negative 3. What do you think this means?
No solution.
When does 2 equal negative 3?
Never.
Never. So that means that this is no solution.
So they're parallel?
These are parallel lines geometrically. And if I write my solution set, I would just leave it empty. There's nothing in the solution set. Right? Now this is one of those things where it's so easy, it's hard. Right? You guys are like 6 bananas minus 6 bananas, and then you just make up a banana because you just can't believe it cancels out. And I don't want to know where that extra banana came from. Right? You smuggled it in. I don't want to know. Okay? If your variable drops out, that can happen. It just is a red flag that it's one of the special cases. Negative 2, 2 is never equal to negative 3. So there is no solution. All right. Next section. Substitution is a perfectly fine method, but we have another one. In 12.3, we have solving systems of equations by the addition method. Right? Sometimes this is called the elimination method, which I'll tell you why in a minute. Right? So the addition method works in this way. So to solve by the addition method, make sure they're both in that standard form of ax plus by equals c. You can clear the fractions, that's optional, but not a bad idea. But most importantly, on step 3, we're going to multiply one or both of the equations in order to create opposite coefficients for one of the variables. In other words, I'm trying to get one of my variables to line up with a common multiple, but 1 plus and 1 minus. Because what happens with, say, a plus 6 and a minus 6? They cancel. What would happen with like a minus 3 and a plus 3? They'll cancel, right? So if we can line up one of our variables so that they're the same coefficient but with opposite signs, then they will be eliminated, hence why they call it elimination, by adding them, which is why others call it the addition method. And some people get really touchy about the name. Okay? I don't care. I just want you to be able to do it.
What page is this on?
So this would be on 717. When we add them together, we eliminate a variable, solve for the remaining variable, and then just like before, we can back substitute to find the missing piece because there are 2 components. So once you find one of them, you have to go back for the other. And then checking is never a bad idea. Now, you don't actually even have to back substitute. If I run this addition method and eliminate x, couldn't I just run the method again and eliminate y? And in that way, you're not having to plug anything in anywhere. Now, where that comes in handy is, did you like plugging in the fraction on the last one? Then the elimination or addition method gives you a method that allows you to avoid fractions always. Sounds good? Avoid fractions? I mean, I could throw a bunch of fractions in your face if you like them. All right. Let's do this. It sounds really wordy, but this is actually really, really easy to pull off. Let's say, for example, that we actually solve (2x minus 5y equals 6) and 3x minus 4y equals 9. All right, so in theory, we could use the substitution method, but there are no limping zebras on this savanna. All 4 of those, you would make fractions when you tried to solve. You guys agree? Mm-hmm. So it works in theory, but in practice, maybe not your favorite thing to do. Instead, let's choose one of our variables to eliminate. So what do you want to eliminate? All right, let's eliminate y. So in order to do that, I need to line these coefficients up. So what is a common multiple that I can line these up at? 20? I can line them up at 20? And I want them to be of opposite signs, which they're not right now, right? So what if I took the first one times -4 and the second one times a +5? So I would have -8x plus 20y equals -24. Do you see how I took that first equation and just multiplied everything by a -4? And then I would have 15x minus 20y equals 45. Do you see how I took that second equation and multiplied it by a +5? You guys okay with that? So what we've done is we've lined up y for elimination, because what's going to happen with a plus 20y and a minus 20y when I add them? Yeah, they cancel out. So I add these two together. -8x and 15x gives me 7x. And then -24 and 45 gives me 21. You guys agree? So x equals 3. How bad was that? Not so bad, right? Now, we could back substitute to solve for y, and there's nothing wrong with that. Or we could just do elimination again, use that addition method, which is good for practice, so that's what we're going to do, to eliminate x. So you guys help me out. So now we're aiming for that x. What is the common multiple? 6. You guys agree with 6? So what would I need to do to that first equation?
3, multiply everything by 3,
Multiply by 3. Then what would I need to do to that second equation?
everything by 2, negative 2.
All right, multiply that by negative 2 because we want them to be opposite signs, right? Does everybody agree? Now, could I have done negative 3 times the first one and positive 2 times the second one? Yeah. Right? That's fine. So if I do what you first suggested, that would be 6x minus 15y equals 18. And then I would have negative 6x plus 8y, so equal to negative 18. You guys agree? So I'm doing that second equation times negative 2. So that's a negative 6x and then a positive 8y.
I was still looking at 1, that's why.
It's okay. There's a lot to look at.
So you cancel x and
Yeah, so we wind up with negative 7y on the left side and we wind up with 0 on the right. You guys agree? So divide by negative 7 and y is 0. 0 divided by negative 7 is just 0. So my solution set, the coordinate pair 3, 0. How many solutions do I have? One solution. It's that coordinate pair 3, 0. Is that okay? What if we tried to solve four x minus 7y equals 10. And negative x plus 7/4 y equals negative 5/2. All right, so some of those zebras are on steroids. So if I wanted to do elimination, or do the addition method, you can tell I learned it with the name elimination, so there it is. Right? But if I wanted to do the addition method, which variable should we line up?
y.
The x's.
Can you do LCD?
You can, but I feel like x should be pretty easy to line up. In theory, it doesn't matter. In practice, some ways are easier than others.
So eliminate x.
How would I eliminate x? What would I do to the first one? Nothing. Then what would I do to the second one?
Multiply by 4, everything.
Multiply by 4. Do you guys see? If I'm lining up my x's, what's the common multiple? 4. So I don't have to do anything to the first one. And the second one I have to do times 4. Are the signs what I want them to be? Yeah, 1 plus, 1 minus. So this is going to be good. If I take the first one as is, that's 4x minus 7y equals 10. If I do 4 times the second one, that's negative 4x. That's going to be plus 7y, and that's going to equal negative 10.
But they're all opposite.
So what happens?
They don't cancel.
Your variables cancel out, which I told you is a red flag that you're on a special case. But unlike the last time this happened, when is 0 equal to 0? Always, right? When was 2 equal to negative 3? Never. When is 0 equal to 0? Always. So what does this mean? Yeah, your solution,
Points in the line.
all points on the line. Because it's actually the same line. If we write it in solution set, so this is going to get a little fancy on you. We're going to have x, y, the coordinate pair, and then that vertical bar just stands for such that. Right? Fancy way of saying such that. such that. Yeah, getting fancy on you. And then just put the line, because that's all the solutions. The line is your solution set. Could I pick the other one? Sure, it's the same line. I assume you wanted to avoid the fractions. Even just writing fractions cause you guys to break out in hives. So this is saying what those infinitely many solutions are. All the points on the line, 4x minus 7y equals 10. Is that okay? So you could find individual solutions. Plug in an x, solve for the y. Plug in a y, solve for the x. You can get all sorts of solutions, but there's infinitely many, so I'm going to list them all or we'll die before we finish one example. But this lists all of them for us. How is that? All right, so there we have our three methods, although the graphing method is, it's great conceptually. In practice, nobody's going to see, you're probably not even going to see a solution like that 1/3. You're not even going to see that, all right? Let alone if it's like 67 over 17. All right? Nobody's going to see that. So in practice, the substitution method and the addition method are good algebraic methods for solving. And on your test, I will specify, solve this system using substitution. So guess what you have to do? Solve by substitution. And then I'll say, solve this using the addition method. Guess what you have to do? The addition method. You can use the other method if you want to check yourself, but you at least have to use the method that is requested. Now, if I say solve using any method, guess what? You can use either method, right? Whatever your heart desires.
So this is the addition method, right?
Yes, and sometimes it's called elimination. I'm sorry, that's just one of those things out there that nobody agrees on. So it has two different names. Elimination. All right. So I promised you this last test. Last test had no word problems, right? This one does. So in 12.4, applications of linear equations in two variables. Now, good news, bad news. Most of these are applications we did before. We're just now going to approach them from the idea of setting up a system of equations, whereas before we were having to set it up as a single equation, and sometimes that was a little tricky to come up with. You guys remember your freight train? All right, so let's see if perhaps we can do a better job solving using systems. Now, if we look at number 6, this is a literal word problem. I mean, it's just math in words, but that's a good place to start. The difference of two positive numbers is 264. The larger number is 3 times the smaller number. Find the numbers. All right. So what is it that this is asking us to find? Two numbers, right? They're asking us to find two numbers here. So what could I call them? I mean, x and y is boring but serviceable. All right. So I could let x be the larger number and y be the other number. You guys agree? So because I have two variables, that means I'm going to need two equations, hence why we were studying systems. So tell me one of the equations. X minus y equals 264. Does everybody see how we get that equation? Where'd that come from? The difference of two positive numbers is 264. So x minus y is 264. Does it matter what order I put them in? Yes. The larger number came first because it's a positive difference. Okay, one equation down. I'll call that the easy one. Scrounge out another equation here. Well, there were two sentences. The first sentence gave us the first equation, so what do you think?
X times
X equals
X times 3x,
X
3y.
X equals 3 times Y.
There you go. The two you guys put it together. The second sentence tells me x is equal to 3 times y. Do you guys see how I got that information? Right? The bigger number is 3 times the smaller number. Literally, x equals 3y. So far, so good? All right, so we have a system of equations. What method might we use to solve this system? Yeah, I think substitution is a great choice here because, I mean, that zebra's not just limping, it's just laid down. So this target is good to go. So in this case, taking that second equation, x equals 3y, solve it for x, I assume. Done. Substitute into the other equation. So instead of x minus y equals 264, 3y minus y is 264. Do you guys agree? In which case, 2y is 264, in which case, y is 132. You guys agree?
Yes.
And then we back substitute. That was a pretty bad little arrow even for me. So x equals 3 times 132. That means x equals 396. We answer words with words. It said find the numbers. So the numbers are 396 and 132. Is their difference 264?
Yes.
If you subtract them? Is one of the numbers 3 times the other number?
Yes.
This is what makes those two equations true. This is our solution. Does that make sense?
Yes.
Okay. Let's look at number 10. All right. This is what's called a mixture problem. Tanya bought 3 adult tickets and 1 children's ticket to a movie for $32. All right. That must have been like 30 years ago.
Right?
Lee bought 2 adult tickets and 5 children's tickets for $49.50. Lee needs the break. It's 5 kids. Find the cost of the adult ticket and the cost of the children's ticket. All right? So they're asking us to find 2 things, right? The cost of adult and the cost of children's ticket, right? So if we want, I was going to go for it. A is the cost of adult ticket. I guess if it's just one. C would be the cost of a child's ticket. Oh, you know what? Shorthand is great, except when it has unfortunate implications. So let's add on apostrophe S ticket. All right, so we're going to put a system together. What do we have here?
3A plus C.
3a plus C equals 32. You guys agree? And we get another equation.
2a plus 5c equals 49.50.
Yeah, 2a plus 5c equals 49.5. Do you guys see how I set this up? Is everybody okay with how I got this information? All right. So we want to solve this system. What do you want to do? Why don't we do elimination or addition? I just gave you the illusion of choice and then steamrolled you, sorry. And let's eliminate the children.
All right.
I really just went through that just so I had that set up. That's all. All right, so what would I need to do? All right, if I did 5 times the first one, then I would have to do negative 1 times the second one. Do you guys agree? So 5 times the first one would make 15a plus 5c equals 160. And then negative second one would be negative 2a minus 5c equals negative 49.5. You guys with me? So when I add these together, our c is eliminated as planned. And we get 13a equals, and that's going to be, is that 109.5? 110.5? All right. Is that okay? Then divide by 13. What do you get? 8.5?
So don't think it's $8.50.
Yeah, that's one of our solutions. So what should we do then?
Plug it in.
You can back substitute, plug it in. That's fine, right?
Or you can just,
Or we could do elimination again. Let's just see what back substituting looks like. So why don't we use the first equation to back substitute? In theory, it doesn't matter. They both work. But in practice, that's a little nicer. So we have 3 times 8.5 plus c equals 32. You guys agree? $25.5 plus c equals 32. And c equals 6.5. You guys agree? Answer words with words. Adult tickets cost $8.50 per person. And children's tickets cost $6.50 per person, plus $50 in concessions. So, mixture questions like that, that's actually the surprise question that I was asked on my job interview when I got hired full time. It was a mixture question. It was M&Ms and peanuts. but it was the same idea. Instead of adult tickets and children's tickets, right? Just make trail mix. Luckily for me, it made a job. Let's look at number 16. Money. 12,000 was borrowed from two sources, one that charges 12% simple interest and the other that charges 8% simple interest. If the total interest at the end of a year was $12.40, or actually, $1,240, I'm trying to like cut our loans there, guys. How much money was borrowed from each source? So we have another mixture question. So for this, it might be nice for us to set it up like a table. All right? So we can keep track of what's going on. So we have two loans. Does amount with two M's or one M?
One.
Okay.
I don't think it's, yeah.
I don't know. You study another language like Spanish or Japanese where spelling makes sense, and English does not make sense anymore. Okay. Origin gets me too, because origen is I and E. But origin in English is both I's. But you can't tell what a vowel is in English just from its sound. English is just crazy. Thank you. So we have two things with each of these. We have the amount we borrowed, and then we have the interest that's built up. You guys agree? So what are they asking us to find here? What is the actual question? How much was borrowed from each source, right? So which boxes are we talking about here? The amounts, right? I don't know either one of them, so I could call them
A or X.
X and Y, right? Whatever suit, you could call them heart and star. I don't care. Right? You're going to solve for them and give me words as your answer anyway. Right? You wouldn't go to your boss and be like, X equals 1,000, Y equals 2,000. No. So you can use heart and star. Your boss will never know. All right. So if we borrowed X amount on the first loan, and it charges 12%, so how much of that X are we going to have to pay in interest? Yeah, 12% of that X, right? So that winds up being 0.12 times X. If I borrow $100, I'm going to pay back $12 in interest, plus the $100 in principal. Do you guys see how that worked? If I took out Y dollars on the second amount, and it's accruing 8% interest, how much interest am I going to have to pay back on that? 0.08Y. Right? You have to pay back 8% of what you borrowed in that interest. Right? So that's going to be 0.08 times Y. So far, so good? And then we know the totals, don't we? What's the total amount borrowed? 12,000. And the total interest that we had to pay? 1240, right? Do you guys see how I got this information? Is everybody okay with how we put this information together? That's half the battle right there. All right, so two unknowns. That means I need to set up my system of two equations. So this table organization is really nice because the two equations should kind of slap you in the face. Yeah, the amount from the first plus the amount from the second should be the total amount. Anybody shocked? Then x plus y equals 12,000 makes perfect sense. Followed up by? Yeah, the interest from the first plus the interest from the second should be the total interest. Did I lose your interest? Thank you, thank you, thank you. I'll be here all night. Now, you can live with decimals, but decimals are ninja fractions. So we can get rid of it if I multiply the second equation by 100. That means I'd get 12x plus 8y. Actually, equals 124,000. I was going to try and read it before putting the zeros in. I'm like, no, I need to put those in first. That helps. All right, so how do you want to solve this system? Either one is perfectly fine. If we do substitution, which variable in which equation? I would suggest picking the first one, and then picking x is fine. So x plus y equals 12,000. If I solve it for x, that means x equals 12,000 minus y. You did say substitution, right? I didn't just make that up. You're looking at me like, I don't know what to do with the zebra. Your lines, you should eat it. So we'll plug it into the second one. So here we have 12 times 12,000 minus y plus 8y, and that should equal 124,000. I can pinch zoom to shrink. What a handy tool. All right, so just to give myself some extra room, I'll just do this on another slide. So this means we have 144,000 minus 12y plus 8y equals 124,000. You guys agree? Combine like terms, that 144,000 minus 4y equals 124,000. What should I do next? Subtract 144,000, so negative 4y would equal negative 20,000. And now divide by negative 4, then y would equal 5,000. Do you see how I solved that out? Is that okay? Then what do I do with that? Plug back in. X equals 12,000 minus 5,000, which means x is 7,000?
Yes.
So they're asking how much was borrowed from each source. So 7,000 was borrowed at 12%. And 5,000 was borrowed at 8%. Do you see how we solved this out? Is that okay? Do you guys know where the dollar sign came from? US. Yeah. US dollars. US. That's how the dollar sign originated. The more you know. Yep. I could teach you so much, but I'd have to charge. All right. Wow, suppose a woodchuckle dies. Yeah, we'll just skip over that one. Let's look at number 22.
Oh, yeah.
How many gallons of 20% antifreeze solution and 10% antifreeze solution should be mixed to obtain 40 gallons of a 16% antifreeze solution? All right, this is literally a mixture problem. All right. So let's look at what we have going on here. So we have the 20% solution and the 10% solution. And then we have the total volume and the substance, in this case antifreeze. But it could be anything. It could be salt in salt water, or it could be acid in an acid solution. So what are they asking us to find here? What would that represent in my boxes? The volume, right? The total volume. How much of this one do you pour and how much of this one do you pour? And you don't just pour the part that's antifreeze, you pour the whole thing. So that means X and Y are here. Now, if I use X gallons of 20% antifreeze, how much is that actual substance? 20% of those X gallons, so 0.2X. You guys agree? And if I use Y gallons of the 10% solution, how much is the actual substance? 0.1Y. Does that make sense? So if I use 10 gallons of that first one, 2 gallons of it is that substance. Does that make sense? All right. I'm not actually sure what the substance in antifreeze is. Something. All right. So once we put that together, what's our goal? To get 40 gallons of a 16% solution. So the total volume there would be 40. And what amount of that is substance? 16% of that 40 gallons. Does that make sense? 16% of that 40 gallons is the substance here. So we wind up with 6.4? You guys agree? I just mathed solo. It's nice if you have my back. All right, what are my two equations? X plus y equals 40.
How did you get 6.4?
I multiplied 0.16 and 40 together because 16% of the 40 gallons should be this antifreeze substance. I figured one of you would have Googled it by now. All right, so then we have 0.2x plus 0.1y should equal 6.4. Do you guys see how I came up with these equations? The total volume from the first jug plus the total volume from the second jug should be the total volume, which you want to be 40 gallons. The amount of substance in the first one plus the amount of substance in the second one should be the amount of substance in the third one. You want the goal to have 6.4 gallons of that substance. All right. Decimals, nobody likes them. So I can get rid of it by multiplying the second equation by 10 this time. So 2x plus y equals 64. You guys agree? How about we use the addition method? Because we could eliminate y very easily. How could I eliminate y? Do -1 times the first one and keep the second one as is. Basically, subtract the first one from the second one. That means we would have -x minus y equals -40. 2x plus y equals 64. And when I add together, I'd get x equals 24. Solve for x, done. Then what should I do? You can either back substitute or you could use elimination again on x, or I guess I should say the addition method. If you want to back substitute, I'm assuming you'd go for the first one, where 24 plus y equals 40, and therefore y equals 16. Do you guys agree? Neck action. You guys on board? You guys up at the front? Like I had glazed eyes because I was making sure the people in the back were on board. You guys? Okay. Answer words with? Words. We'd use 24 gallons of 20% antifreeze and 16 gallons of 10% antifreeze. So if I take 24 gallons of the 20% stuff and 16 gallons of the 10% stuff and pour it together, I get 40 gallons total, and 16% of it is antifreeze, whatever that material is. Mm-hmm. Is that okay? Let's do another one like this.
It's ethylene glycol. Or propylene glycol.
Okay.
Mainly water also.
Yeah, usually a solution is in water. So water and propylene glycol?
Propylene glycol.
Sure.
Or ethylene glycol.
Pro tip, don't drink it. Let's look at number 28. Apple juice, we can drink that. Sylvia wants to mix a 40% apple juice drink with pure apple juice to make 2 liters of a juice drink that is 80% apple juice. How much pure apple juice should she use? Now this is going to be one of those that's actually so easy it's hard because of the word pure apple juice. So I'm going to set it up. We got the fake stuff and the real stuff. Come on, 40% apple juice. What's the rest of that? Water? Sugar? No. All right, so what we have here is the total volume and the substance. In this case, apple. All right? If you've actually had real apple juice, it's not clear. It's not. That's processed stuff. All right. So what are we looking for here? So we can do x of the fake stuff plus y of the real stuff. Now, if I use x liters of the fake stuff, how much of that is actual apple? 40% of those x liters. So that would be 0.4x. How much of the real stuff?
80, 40, 60.
The whole thing, 100%. Right? If it's real apple juice, it's 100% apple juice. So this one is 100%, all y liters. If I have y liters of pure apple juice, how much of it is apple? The whole thing.
Common sense type question.
Yeah, that's what I'm saying. It's one of those things. It's one of those things that's so easy it's hard. They didn't tell you it's 100%, but that's what real apple juice means. It's 100% apple juice.
Where's 80% come from?
Well, now that's a good question. That's the goal. Our goal is to make 2 liters of 80% apple juice.
So the volume is the 2 liters.
So in our goal, it's 2 liters, and 80% of those 2 liters should be that real stuff, which is 1.6. Yeah, there are 2 ways that they just do this mind twist on you. Pure apple juice means all 100% is apple juice. What would pure water be?
Is it 100%?
Well, how much apple juice?
No apple.
0. That's the other one that's out there, right?
Water and apple.
If you want to dilute the concentration, you could just add pure water. That would be 0% juice. So that 100% and that 0%, so easy, it just messes with your brain. That's why I did this one. Then what are my equations? X plus y equals 2, and then 0.4x plus y equals 1.6. How should we solve this? We had 1 vote, everybody else just drooled. Substitution is fine.
You can multiply by 10.
But I'm going to use addition. And let's eliminate y. So I could do 10 times the first one and negative 10 times the second one. You guys agree? That would be 10x plus 10y equals 20. And then that would be negative 4x minus 10y equals negative 16. In which case I get 6x equals 4, meaning x is 2/3. You guys agree? Then we could back substitute. I'm assuming you want to back substitute into the first one. 2/3 plus y equals 2. That means y equals So 2 would be 6/3. Minus 2/3 is 4/3.
2 minus
You guys look so shocked. Like you have this look on your face like, oh my god, apple juice.
I'm still like running around
that.
mathematics.
Let's see, let's see. 2 minus
How much
2.
of pure apple juice is apple juice? 100%. All of it. How much of pure water would be apple juice? None of it. 0%. Those are the weird cases. All right, just watch out for those. All right, so the question here is actually just asking how much of the pure apple juice do we need? And in our case, that was represented by Y. So we need 1 1/3 liters of pure apple juice. So they just wanted to know how much pure apple juice. That's the real stuff.
4/3.
Yep. 4/3 of a liter or 1 1/3 liters, right? Usually food products is where mixed numbers see their heyday. Right?
Pure apple juice or pure water? I'll leave that up to you. Oh no, another one, please.
A boat takes 1.5 hours to go 12 miles upstream against the current. It can go 24 miles downstream with the current in the same amount of time. Find the speed of the current and the speed of the boat in still water. All right? So the boat's got some source of power. We'll make it a motorboat. So its motor is pushing out some energy, right? As you go upstream, you're going to be slowed down, right? And as you go downstream, you're going to be sped up. Why?
Because you're pushing it.
Yeah, the current is moving too. So going against the current slows you down, and with the current speeds you up. Make sense? All right. So here we have distance, rate, and time. And actually, that box is just so nice, we're going to use it. So what are the two things they're asking for?
The current and the speed of the boat.
Yes. As you go upstream, how are those two related to each other? The speed of the boat based on its engine alone and the speed of the current. How would you make numbers smaller? Yes. So the rate is going to be B minus C. As you go downstream, though, what's going to happen? So it's going to be B plus C. That's your speed going downstream. Does that make sense? What else do we have here?
The half hour, the distance and the time.
They gave us both the distance and the time, right? Now, if you guys remember, you guys didn't like setting these up previously. But now it's pretty straightforward. Upstream, that would be 12 miles in 1.5 hours. Whereas downstream, that would be 24 miles in 1.5 hours as well. So this was pretty straightforward to fill in. You guys agree? The downside is I should get two equations. But that's not really that bad because we remember dirt, right?
Oh God.
Distance equals rate times time. So that means 12, right, should equal B minus C times 1.5. And 24 should equal B plus C times 1.5. That was easy, right? Yeah, it should be 24 though. So if I were to rewrite this in standard form, that would be 1.5b minus 1.5c equals 12. And it would be 1.5b plus 1.5c equals 24. Do you guys agree? Was this easier to set up than it was before? I think so. I think it's more natural, but they make you wait for the system. So what should I do?
Well, those already canceled.
Yeah, so addition method. Eliminate
C.
C. You don't have to do anything. They're lined up for it. So just keep the first and second one completely as they are. If I add them, that winds up being 3b. The C is canceled as planned, and we get 36. Which means B equals 12. You guys agree? I could back substitute, or I could just eliminate B. How would I eliminate B?
Minus.
Yeah, keep the second one as is and just do -1 times the first one. Or, I mean, you could do -1 times the second one. Whatever floats your boat. That means we get -1.5b plus 1.5c equals -12. And 1.5b plus 1.5c equals 24. So b is eliminated when we add down, and we get 3c equals 12, meaning c is 4. It's not just me, right? This is easier than the first time we did it? I think so. So the boat's engine is putting out 12 miles per hour. In a 4 mile per hour current. Does that make sense? So going upstream, you're going 8 miles an hour, and going downstream, you're going 16 miles an hour. Hence why you went twice as far downstream. Ah, it's like math makes sense. We'll do another one. Let's look at number 33. I mean, I don't know who Tony Markins is, but here we go. We're going to help him out. So Tony Markins flew from JFK Airport, which is in New York, to London. It took him 6 hours to fly with the wind and 8 hours on the return flight against the wind. That's because there's, the jet stream, and that's how the wind rotates. If the distance is approximately 3,600 miles, determine the speed of the plane in still air and the speed of the wind. All right. They took our boxes away from us, but we still know how to do this. So you have headwind and tailwind. All right. If you have a headwind, it means you're flying against the wind. If you have a tailwind, it means you're flying with the wind. Makes sense? You're learning some industry lingo. And then for each of these, we have a distance, a rate, and a time. So what do we have? Number 33. So flying against the wind, that headwind.
3,600.
Yeah, we went 3,600 miles in
Both times.
8 hours. All right. And there, the wind was working against the plane. Then with the tailwind, we covered that 3,600 miles in 6 hours. You guys agree? That was when the wind was working with the plane. Do you guys see how I put that together? When you were flying against the wind, it took 8 hours to cover that 3,600 miles. When the wind was working with you, it took 6 hours to cover that 3,600 miles.
And P stands for
The plane. Sorry.
Plane.
P is the plane, W is the wind. X and Y, if you want to be boring, it's okay. As long as you get the right answers, I'm okay. Am I not entertained? Eh. Let's put some equations together. Go digging in the dirt. $3,600 should be P minus W times 8. And 3,600 should be P plus W times 6. Distance equals rate times time, literally. So if I put this in standard form, that means 8P minus 8W equals 3,600. And it means 6P minus 6W equals 3,600. And how do you want to solve this one? Well, you might happen to notice that I actually have a common factor across that second equation, don't I? I could divide everything by 6. Oh, snap. So P plus W equals 600. We can still use the addition method. It's just going to be easier now. So who do you want to eliminate? I'd want to eliminate the wind too. So what would I do? So keep the first one as is and do 8 times the second one. That means 8P minus 8W equals 3,600. P plus 8W equals 4,800. Add down 16P equals 8,400? You guys have my back on this? I'm not feeling the support from you guys tonight. Divide by 16, and what do you get?
525.
525 is good. We can back substitute to find W. And in this case, I think you want to use the second one. I mean, maybe I'm presuming to speak for you, but that means 525 plus W equals 600, which means W is 75. So the airspeed of the plane is 525 miles per hour. And the wind is 75 miles per hour, which is almost certainly the jet stream, because that's not just regular wind. Is that okay? All right. So no more word problems. How about we do some more graphing? Our last section is 17.5, where we talk about linear inequalities and systems of linear inequalities in two variables. All right? So we solved inequalities before. For example, this is just kind of a flashback. How did we do the solution for x is greater than or equal to negative 3? Let's do it in steps. We went to negative 3. We chose a closed circle. And then we shaded, right? In this case, we would shade greater than, so to the right.
Oh, that's why.
You guys agree? What about x is less than 8? How did that work? You go to 8, and then we would put an open circle. And then we would shade that to the less than side, which in this case was to the left. So, for example, was negative 4 a solution in that first inequality? No, it's not true, right? Negative 4 is not greater than or equal to negative 3. Was 0 a solution? Yes. So would you say that on that boundary we had a true side and a false side? All right. Same thing here. Is 0 a solution for x is less than 8? Yes. Is 10 a solution? So once again, we had that boundary and there was a true side and a false side. And we wanted to shade the true side, right? So in two variables, we're going to be doing the exact same process, except instead of on a number line, we're in the plane. And that gives me a slight twist. All right? Actually, I don't like their instructions at all, so we're going to ignore them. Solving inequalities in two variables. First thing, just look at the equations, right? Just like in order to do x is greater than or equal to negative 3, we had to go to negative 3. And to solve x is less than 8, we had to go to 8. So you start with the equations. Then we had to choose whether it was a closed dot or an open dot, right? So in the two-dimensional version, we're going to either do a solid line or a dashed line. But it's the same analogous choice. And what was the last thing?
Shade.
We shade. Now, on the number line, it was super easy to figure out which side to shade on. In the plane, it can be a little bit tougher. So we'll have to be a little more cautious. Let's say, for example, that we have 2x minus 3y is less than 9. So here's a linear inequality in two variables. First up, make it an equation. 2x minus 3y equals 9. Because that we can graph. We can graph a line. I mean, fingers crossed. I'm hopeful for you guys. So, a couple ways that we could do this. We could either go by the intercepts or we could put it in slope-intercept form. Either way is fine. If I want to put it in slope-intercept form, I would just solve for y. So I would subtract the 2x and divide by negative 3 to get y equals 2/3 x minus 3. You guys agree? When I graph this, will I graph a solid line or a dotted line?
Dotted.
Why is it going to be a dotted line or dashed or whatever, like your hopes and dreams?
Because you don't. Because there's no equal to.
Yeah, you don't have the equal to with that inequality. So like you would have chosen an open circle before, we'll choose a dashed line now. So we'll make our axes. And we can graph this by using slope-intercept. That's one way to do it. My y-intercept is negative 3. And then the slope is 2/3. So rise over run, right? So rise 2 and run 3. And then we're going to connect that with a dashed line, which I have a tool for so I can show it off. It's a little dotted line there. I didn't know you'd not seen that before, and now I get to show off. All right, but it wasn't an equation. It was an inequality. So the last thing we have to do is shade. To do that, pick a test point. So what's a great point to plug in? 0, 0. As long as it's not on the boundary, you can use it as a test point. So let's plug in 0, 0. So if I do so, I get 2 times 0 minus 3 times 0 is less than 9, which means 0 is less than 9. Is that true or false?
False. Yes.
0 less than 9 is true, right?
So you can shade left, but right?
So that means this test point was on the true side. So we will shade. Now, in one variable, we had interval notation that we could go to from there. There's no two-dimensional equivalent, so graphing the solution is the answer. So what if then I give you 2? Let's say I give you negative x plus y is less than or equal to 3, and 2x plus y is greater than 6. What do you think I'm going to do? Exactly what we just did, except twice. There's 2 lines. That's it. So the first step is to make them equations. Negative x plus y equals 3, 2x plus y equals 6. And those are going to be really easy. Those intercepts are all super easy, right? When I graph them, that first line is going to be solid. The second line is going to be dashed. And then we're going to have to do a test point. But I can't know what to test until I see what I've got, right? So let's graph those boundaries. So we'll do our axes. And then easiest way to graph this would be by doing the intercepts. So for the first one, the y-intercept is 3, whereas the x-intercept is -3. So my x and y-intercept, -3 and 3 respectively. There's my line. For the second equation, my y-intercept is 6. My x-intercept is 3. So I've got my x and y-intercepts there.
Why is the first one a solid line?
Because it was less than or equal to.
Okay.
Just like we would have chosen the closed dot before, we choose a solid line there. That's a good question. Right? Oops. That wasn't my line tool. That was ugly. So here's my second line. So how many regions do I have? There's 4 regions. But how many test points do I need? Just 1. Now, in theory, just 1. You can do more if you need. Can I use 0, 0? As long as the line doesn't go through it. So let's see what happens. So when I test using 0, 0, that means -0 plus 0 is less than or equal to 3. And it means 2 times 0 plus 0 is greater than 6, right? You guys agree? So I get 0 less than or equal to 3. True or false? That is true. 0 less than or equal to 3 is true. Then I get 0 greater than 6. That is false. So this means when I did the point 0, 0, I was on the correct side of the solid line, but I was on the wrong side of the dashed line. So can you tell me where I need to go? Cross the dashed line without crossing the solid line. So do you see which region I'm going to shade? The region out to the side. Do you guys agree? Now, if you have doubts, you can pick another test point just to verify that's the true region. Let's say you picked 4, 0. You could do 4, 0 to verify that that works.